If the history of the earth was a basketball game, at what point in the game will the humans show up?
Let's first think about how long a basketball game is in the NBA. We have 4 quarters that each last 12 minutes, so we're talking about 48 minutes. 48 minutes of regulation play. I'm not considering halftime and the timeouts and the commercial breaks and potential overtime. I'm just talking about regulation play. We can think about how the numbers might change if you think about the total duration of a game, including timeouts and commercial breaks and everything. That might get you closer to 2 or 2.5 hours. But 48 minutes we can actually convert to seconds because we know that there are 60 seconds per minute. Times 60 seconds per minute. And this is pretty straightforward multiplication. We can just say 48 times 60 gives us, well, we got this 0 here, and then 6 times 48, 6 times 8 is 48, and then 6 times 4 is 24, plus 4 is 28. So there's 2,880 seconds. 2,880 seconds during regulation play. Now let's think about the actual age of Earth. We estimate that the Earth, and actually the entire solar system, which was all formed roughly at the same time, is 4.54 billion years old. So let me draw that here. And we're going to make a comparison, so I'm going to draw it as the same length. So 4.54 billion years old. And just to give a sense of how large of a number that is, a billion is 1,000 million. So we could also write this as 4,540 million years. Or we could write it as 4,540,000 years, or millennia. 1,000. Or we could just write out the number as 4,540 million. 540 million years, which seems kind of old. But now let's think about how long anatomically modern humans have been roaming the surface of the Earth. And here we estimate that anatomically modern humans have been on the surface of the Earth for about 200,000 years. 200,000 years, which seems like a reasonable amount of time, but we'll see it's a very small fraction when you compare it to 4.54 billion years. So let's say that that's that little there, and I'm actually overdoing it when I'm drawing the diagram. So that right over there is the amount of time humans have been, 200,000 years. And I'm actually drawing this way too big. But what we want to figure out is what is that equivalent length in seconds on a basketball game? Or another way to think about it, 200,000 years is to 4.54 billion years. 4.54 billion years as the number of seconds. So let's just call this thing right over here x, as x is to the total number of seconds in a game. So 2,880 seconds. 2,880 seconds. Just like that. And one way that we can do this to solve for x, and this is kind of more basic algebra, but just as a reminder, if we want to solve for x here, the easiest way is to multiply by 2,880. And that will cancel with this right over here, but we can't just do it to the right-hand side. We also have to do it to the left-hand side. And so if you multiply both sides by 2,880, so multiply both sides by 2,880, you get that x, the equivalent number of seconds in a basketball game, if the history of the Earth was a basketball game, when the humans would show up, is equal to the fraction of Earth's history that humans have been around, that's this part right over here, times the number of seconds in a game. So let's think about what we get there. So we're going to have the fraction of Earth's history, so 200,000 divided by 4.54 billion. There's a couple of ways I could write it. I could write it 4.54 E9, which literally means 4.54 times 10 to the 9th, or 4.54 times 1 followed by with 9 zeros, or 4.54 times a billion, which is exactly 4.54 billion. So I could write it like that, or I could just write it out. I could write 4 billion, let me be careful, 4 billion 540 million, and now I'm doing the thousands, 2, 3, and now I'm just doing the 1, 2, 3. So this is 4 billion, and then I should have 9 places after that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this expression right here is a fraction of Earth's history that anatomically modern humans have been around. And then I'm going to multiply that. I'm going to multiply that times the number of seconds of regulation play. 2,880. And now, drum roll, we get 0.12. We could round up 0.13 seconds. So we get x is equal to, or I could say maybe approximately equal to, approximately 0.13 seconds. And so just to imagine, if the history of Earth were regulation play of an NBA game, and let's say this game is at the end of this game, there's a buzzer beater shot that wins the game. The humans don't show up in the game until the ball has left that final shot taker's hands and it has just about to enter the basket. That's when the first humans 200,000 years ago will show up. So a little over 1/10 of a second before the end of the game. And since we already have our brains in this mindset, I'll throw out another interesting question. Okay, humans have, there's just a flash that they've actually shown up. Just, the ball's about to go into the basket. We have a little over 1/10 of a second left in the game. Think about when the dinosaurs went extinct. And I'll give you a hint here. The dinosaurs went extinct. So we believe an asteroid hit the Earth, or this is kind of a meteorite. This is the current theory. Meteorite hit the Earth. Mass extinction event 65.5 million years ago. So if we think of that 65.5 million years ago relative to the history of the Earth, and if the history of the Earth were just a regulation play of a basketball game, when did that happen? Well, once again, let's get our calculator out. So what fraction of the Earth's history ago was this? 65.5 million. I could write this as 60.5 times 10 to the 6th, which is that. And then I'll just divide that by 4.54 billion years. So times 10 to the 9th. And so this is the fraction of Earth's history that has happened since the extinction of the dinosaurs. So a little more than about 1.5% of Earth's history has happened since the extinction of the dinosaurs 65.5 million years ago. And if we're talking about a basketball game, let's just multiply that times the number of seconds in a basketball game, 2,880. And we get about 41 seconds. So with less than a minute left in the fourth quarter is when the meteorite hits the Earth and the dinosaurs go extinct.